This is the Web Platform Podcast, episode number 94, Reactive Programming in JavaScript. This week, I am your host, Danny Blue, and with me is Leon Revel.
Hi, everyone.
Amel Hussein.
Hi, everyone.
And our very special returning guest is Gleb Bahumutov.
Hello, everyone.
Hey, Gleb. So in case anybody that hasn't gone, Gleb, do you remember which episode it was we had you on before?
A couple of weeks back.
Yeah, it wasn't too long ago.
Yeah, it was actually a month ago, and it was I think it was Cypress.io. You came on as an early adopter, and we had the founder of Brian on as well.
Yeah. So if you want to hear more Gleb, go back and listen to that episode. We'll post it here. But what we want to talk about this time, first off, is Gleb, you just got back, but you attended Ozcon this year.
That's right, a month ago, yes.
So we really just want to start there. How was Ozcon? It was showing up in a bunch of different places. So what was it like? What was it like being there? And this was also your first time speaking there, correct?
That's correct. It was my first time attending and first time speaking there. And Ozcon is an O'Reilly open source conference. It's the largest open source conference in the world. A couple thousand attending. I think it's around 5,000 attending. It was quite large.
Yeah, and that's not bad at all.
It's not bad at all. And it's been growing every year, if I understand correctly. I think it's almost 20 years in a running. So you can imagine, the first one probably was tiny. This year it was in Austin, Texas, which is a first. It usually was in Portland, Oregon. And this year, Ozcon also will have a second European edition, first time ever. So it will be in September, I believe, in London. Well, I probably will not go there, but just if you're in Europe, you probably want to attend that. And the interesting thing, it's not just the number of attendees, it's also there is also an expo hall and bunch of companies that are involved in open source. And you can definitely imagine, your GitHub, your Heroku's, but every major company was there on the expo hall, right? Like Microsoft, HP, IBM. Pretty much any company that you're using right now or whose products you're using was represented. And that shows that open source is no longer like this niche or this kind of, hey, my side project. Every major company has part of a business involved with open source. So that was great.
Yeah, no, that's awesome. That's what 5,000 people. That's a lot. That's kind of intimidating. I'm assuming that you did not speak to all 5,000 of them, but was it intimidating at all? Knowing that there could be so many people?
It was a little intimidating, but the mitigating factor was the conference was so large. It had 2 full days. Each day had 10 tracks in parallel, right? So there was a track for architecture, track for open source financing, track for security, and so on. So under the best of circumstances, I probably spoke to, in front of less than 200 people, which is still intimidating.
Yeah,
but,
that's what I say. Even so, that's a lot.
It's not too bad. The organizers were exceptional. Video, the video setup, the support, right, the organization and timing was just impeccable. I could not have asked for better organization.
Yeah, I saw your Twitter post with the photo of the thank you letter that they sent you with the little animal.
Yes,
absolutely adorable.
They do take good care of speakers, and they're absolutely incredible people.
Yeah, that's great, especially when a conference is that large. Every once in a while, you'll hear horror shows about something that's been hyped up a lot, and it just all falls apart. So it's awesome that it's being run that well. So with that much content and that many that many people attending, that many companies attending, what was some of your favorite stuff that you saw?
So one interesting thing is that about 50% of all presentations somehow heavily involve Docker. Docker is absolute boon to open source and community. I think just because it makes working so much simpler and collaboration so much simpler. One of the cool things during the keynote, I think first day, I think the CTO of Docker he did a 10-minute presentation during keynote, and he live on stage open sourced 3 big projects from Docker community, just like clicked the button on GitHub and made it public. So that was kind of cool. But Docker was everywhere. Every project that was trying to show technology, had source code on GitHub, and to make it, runnable, they all said, "Here's how this is my Docker file. This is the services that set up." So that was kind of running theme across all talks. But that was very impressive.
Well, it seems like what Docker has done for the open source community, or just for technology in general, is it's the English of how we can all deploy, and set up, in the same way. And so they've kind of solved a really big problem with us having to spend like a week customizing our setup. Now we can just put it up on Docker and someone else can run it. It's very, very, like, I'm excited to see what happens in the next few years as people now collaborate more and cross-pollinate more.
Sorry, go ahead.
I was just going to say, there's no surprise it's got so incredibly popular for so quickly. Docker has it. It really does solve a lot of problems for a lot of people. So I can kind of see why it's everywhere now.
Well, if you think about GitHub, right, made open source popular because it made the source code sharing easy. Docker actually makes binary or built executable sharing very simple. So it kind of is the next logical step.
Yeah, it's a nice way of putting it.
Yeah, and for anybody that hasn't listened, we actually during Ozcon we had somebody from Docker on the show talking a lot about that stuff, which was awesome. Like, I actually think he was great because I think he actually did it from the hallway on his phone, and it actually came out awesome.
That's pretty cool.
Yeah, but Gleb, the reason that we have you here is that we do want to hear about your talk. So before we get into a lot of specifics about it, just tell us very high level, what did you speak about and how did you arrive at that topic? If you can't tell from the title.
So my title was, I think, a JavaScript Journey to Reactive Programming, and this is a topic that I've been working on and speaking about for the last maybe 2 years. So Ozcon was kind of a culmination of maybe 5 talks that I've done over 2 years for different audiences. And the talk kind of was not about, why reactive programming is something, important that much, but more like, if you think that you want to program in functional reactive style in JavaScript on a web or on a server, how do you actually do that? How do you take your team who has very different, levels of expertise in different topics, and how do you go step by step, all the way to functional reactive programming, so that you don't try to kind of jump, to the next level 10,000 feet up? So the talk was more like, hey, here's what you can do using traditional imperative programming style, kind of like think C++, but in JavaScript. And then here's a problem that's hard to solve, right? Your code becomes mangled and you cannot take the next step, right? You have too much code and it becomes hard to reason. And here's another technique that makes it simpler, right? So for example, object-oriented style, for example, that separates, your concerns into classes or objects.
Yeah, before we kind of go any further, if we could just take one step back, and if you can kind of describe to somebody who's never really heard of reactive programming before, kind of what it is, and how it's maybe different from traditional or other programming methods, that would be really cool.
Yes, absolutely. So think about, imperative style, right? Your Visual Basic kind of programming style. You execute statements, and the statements just say what computer should do, right? It's imperative. It says, print this, multiply that, and so on. But you quickly, reach the limits of a programming style just because everything becomes very intermingled. And it becomes hard to do asynchronous programming, for example, or parallel programming, things that you have to do in real world. So people have invented reactive programming that instead of trying to say, do this, do that, execute method on this object, describes kind of like data flow or event flow through your code. So your concern is not with what should be done, your concern is to describe, here's an event that happened, let's say mouse click. Once it happens, for example, you can process it, send a request, receive a result, show a message on a screen. But you don't say send request. Instead, you kind of say, when this event happens, I want to subscribe to it, and I want to process it. And once that finishes, I'll subscribe to that complete event, and I'll send something to the server. So instead of describing dependencies as saying, hey, do that, or do this, instead you say, well, when that event happens, I'll just do my part, and I'll generate another event so someone else can subscribe. So you never know who will respond to what you've done. Instead, you only care about inputs to your little piece of code. And a related topic is functional reactive programming. When you do functional reactive programming in any language, but JavaScript in particular, you kind of use standard methods that operate on data lists, like think of your array methods, like .map, .filter, .reduce. And functional reactive programming just extends this idea, but instead of arrays that have .map, .filter, you have observables or event sources. And you can say, well, this event source, .map, and then the function will process each event that's generated. There are other types of reactive programming, and the most traditional example that everyone has seen and used are your Excel spreadsheets. You know how you can enter cell numbers, right? But sometimes instead of a number, you can just say equals, and then the ID of a different cell, like $A$1 plus $A$2. And this way you kind of create a little reactive cell. And whenever you change something in the first cell or the second, the third one updates automatically. So this is a classical example of something that reacts to data changes without you setting up any additional code, right? The first cell that was used in the third cell never says, hey, when I'm updated, hey, cell number 3, update yourself, right? It never does imperative style. Instead, the cell 3 will react to changes in its inputs and will update itself. So that's an example of reactive programming. But in JavaScript, in our code, it's not spreadsheet. We have to kind of use little functions, and we have to create these pipelines of events and observables, and use all little functions to actually process events and generate, something that someone else can subscribe to.
So you kind of mentioned a few already, but what are like the main benefits of reactive programming over more traditional methods? Kind of if you can kind of highlight the obvious ones that usually the main selling points.
So if you think about any realistic world application, right? The hardest problem is probably synchronizing events and synchronizing processing. Sometimes you want to send a request to the server when the user clicks a button or enters text to search for, right? And then the hardest problem, for example, when you send a request to the server when the user enters search text is every time the user, for example, enters a letter, you want to generate a new search, right? And so you generate a new request. And so now the user typed 10 letters, you have 10 research queries that went to the server. Well, you don't want the first 9, you just want to grab the last one, right? Because the first 9 are already out of date, the user doesn't care about. So kind of synchronizing this event and saying, well, discard the first 9 results and only take the last one is something that's hard to solve with any other technique, any kind of imperative programming or callbacks or promises. But for example, this method to discard everything and just consider the last event or the last response is solved with a single operator in reactive programming libraries, flat map latest, for example. So all these problems that arise in synchronizing events in real-world applications are bread and butter of reactive programming. Its main purpose is to make working with different events and think about them and making them explicit and making the data flow explicit and very, very simple. That's what reactive programming is all about. So that kind of maps naturally to real-world applications. And the examples and problems that I deal with every day.
Wow.
So,
Go ahead, Leon.
oh, I was just going to say, so would you only ever really use reactive programming when dealing with kind of user events or stuff like that, or is there kind of, or can you use this kind of the idea kind of everywhere in your application? I know that's kind of a difficult question because obviously your application doesn't often do something really unless the user's interacted with it. But for example, let's say you get a push notification or something along those lines that the user hasn't directly initiated. Can you use this kind of idea in those kind of situations as well, like just anywhere where there's streams of data?
I would say so. I think the natural kind of example is, for example, or for me was kind of type ahead search example where you type and you get results back and you want to maybe buffer results and so on. Mm-hmm. But now once you get this idea, you start thinking of everything that happens as an event. Mouse clicks is an event. You want to do something in response to that. But maybe, for example, you want to do something but limited to 1 time per second, even if a user clicks the events many times. So all of a sudden you're like, well, that's a stream of events, and Reactive gives me operators like buffer that deal with that problem very, very naturally. So mouse clicks is one event, button clicks. My synthetic events like search that I create is a good example that Reactive deals with. Mm-hmm. Generating or processing WebSocket events, like the real-time events from the server. Reactive deals beautifully with that. Cool. The next wave of Internet of Things, right? The little devices that are embedded everywhere. They all kind of generate little, hey, here's new piece of data, temperature, sensor, door opened, someone entered the room with phone, right, that I recognize, and so on. These are all sources of events, and for framework of the future, so to speak, right, Reactive would be extremely good technique. So for Internet of Things.
So so a lot of the examples that we're talking about, a lot of it has to do with asynchronous.
Yes.
I mean, those are problems people have been trying to solve forever. For the best ways to handle asynchronous information, and you've mentioned data and streams a little bit, which is kind of the core around it. But what I want to talk because there are a lot of patterns that you can follow. The observable pattern is not new, right? Like that, the very basic vanilla pattern for observables is not new. A lot of things around it, which we'll try to get into a little bit later, which are the specific libraries like RxJS, which anybody that says they're doing reactive programming is probably using. What I wanted to ask about is specifically how the observable pattern itself differs from something like a pub/sub pattern, right. which pretty much everybody that's worked in JavaScript will be used to, because all that means is you have something that dispatches events and you have something that listens to events. Right. Now, on the very outset, that sounds very similar to what you were talking about, because an event happens and then you can subscribe to that event and then do something after it happens. So, can you? And like I said, you've already talked about it a little bit, but for me, when I was first starting to learn about some of these things, that was one of the things that was a hurdle for me, because I didn't quite understand not that I didn't understand the difference. I didn't understand why that one was better in a lot of people's opinion than the other.
Right. So let me step back and talk about async, right, problem, because that's what the solution is for this. It's a huge problem, and there are multiple solutions. The built-in kind of mechanism in Node or in JavaScript was to use callbacks, right? Just register callback and so on. And this has a huge problem because the code just becomes a nightmare, a pyramid of doom. Callbacks become nested and so on. So the solution that people came up was to use promises, right? That's kind of natural. Instead of passing a callback, you get an object back, and then you can register, hey, if promise is resolved and succeeds, call this function. And if it fails, call another function, and so on. But the problem with promises that we found in our code was they're kind of like a bullet. Or you can only fire it once, and it's done. So promises are very, very good at handling a single asynchronous action. Make a HTTP request, you get result, that's it, you're done. If you want to make a second request, you have to make completely brand new promise object. And so a lot of our code became this huge amount of boilerplate code, just creating promises and resolving them, creating new promise and resolving them. And now think about mouse click. So every time I click a mouse and I want to do a server-side event, right, and like fetch something from a server, that means I have to construct a new promise object, wait for HTTP response, and then do something else. So amount of boilerplate code just to handle this case seems a little bit too large, right? And especially if you want to pass promise around, you will never know who actually subscribed to that promise, or is it really done, and so on. So that's where maybe event emitters or pub/sub comes into play, because a single asynchronous event can just notify everyone that's listening, hey, I'm done. And I love pub/sub. We use it a lot in our Angular applications because you can broadcast events and then widgets can update themselves. But the problem with that is that a pub/sub or event emitter is almost like a person with a megaphone, right, with a loudspeaker. Like, he can shout very, very loudly, but he's not interested in actually listening to anyone else. So it's easy to actually send a message. But for example, if you want to send a message and then do something when someone else responds, right, all of a sudden pub/sub becomes a huge issue, because there is no way you can say, hey, broadcast this message, and when you get this particular result from my message, right, kind of like unique ID, then I'll do something else. So for example, if you type search and you want to update both the screen and also do HTTP request, and then put the data that you get back, all of a sudden pub/sub becomes pretty hard to actually use. And the problem with pub/sub is that you broadcast a message and someone can subscribe. So think about event emitter and then .on message name, do something else. What's the semantic meaning of this .on? Right? There is no meaning. It's just a subscription. Now compare this to array methods, right? When you have an array, you can do .map and then pass your function. And this means for every item in an array, I'll run this function and then I'll generate another array. You can think of .filter. For every item in an array, call this function, give it an item, and then if it returns a truthy value, put it in a new array. So there is semantic meaning for every array method. There is no semantic meaning for anything that event emitters do. There is only .on. So when you try to actually write several actions that happen one after another in asynchronous fashion using event emitters or pub/sub, all of a sudden it becomes really hard to actually write them, because it's all .on, .on, .on. And so you're like, well, I wish I could just have like .map or .filter using event emitters, right? And do asynchronous stuff on my event source or my array, but each step should be an event emitter because it's very powerful. And this is actually, the event emitters becomes almost like a bridge. If you're comfortable with array methods and you're comfortable with individual event emitters, you can take event emitters, add a little bit of boilerplate code, and make a library of event emitters, returning event emitters and implementing .map, .filter, .sum, and all these methods that you want, .buffer, right? And so all of a sudden you can write this thing where mouse click, .map, make a call to HTTP, but it's an event emitter, and then you can subscribe and say update the screen, and another subscription to update the search box or something like that. And so event emitters in this case is an intermediate step, and then you jump all the way to reactive programming, just because your chained event emitters is equivalent to observables chained together in reactive programming, and that's kind of how you derive it.
Well, that was a great
That was
answer.
that was an excellent answer. Thank you very
Thank
much.
you. I just learned a lot. The things just clicked for me. Thank you, Gleb. So we have a question about just a more general architecture patterns that I've been seeing. Obviously, with our devices being more interactive now, we're seeing things like Firebase really kind of take off, right? So these real-time push databases, and so that, I mean, I think of Firebase and Rethink as almost like reactive databases, right?
Yep.
Because they're also being proactive and just saying,
Yep.
oh, you know what, this changed, so here you go. And so, can we kind of maybe talk about what you think a modern web app or a modern web app or even a mobile web or Android or iOS app should kind of, what are some new architecture patterns that we can start thinking about as we develop new applications?
That's an excellent question. So first of all, Firebase, I haven't played in it in the last year. I tried it many times, before, and I always hated its API. It's weird. It's all over the place. It uses different patterns for different things, but it's whatever. But you just named another one, RethinkDB. So RethinkDB is an absolutely incredible database that's very modern, and it actually has this nice feature where you can execute a query, and the query could be very complex. But instead of just executing the query, getting the result, you get back an observable. And so the query kind of stays live in a database. So every time there is a new item that matches that query, you get back an event and say, oh, here's a new item that matches your query. So you can kind of keep this open, long-running connections to the database and get back results as they get created in a database by someone else. And so RethinkDB actually plays their cards very nicely. Just in the last month, right after Ozcon, and the RethinkDB team was at Ozcon, and I talked to them about that, they open sourced a web app or a backend API, so to speak, that's built on top of RethinkDB, but uses WebSockets so that you can just connect to data, execute a query, and then you get open WebSocket connection, and you get results as they come in. So they kind of build this backend for web apps to take advantage of live queries in the engine, and that's very good for them. This is absolutely the right decision, and this is what a modern web app should deal with. Not with, hey, I'm going to make an AJAX request and I'm going to get the data, I'm going to display the data, and I'm done. No, that's not what users expect, right? A modern web app usually does that, but in addition, probably opens a WebSocket and has some other source of information to get live updates, right? Think of your Twitter, that if you refresh, right, you get the AJAX request to get all the messages. But then it keeps open WebSocket connection and shows you indicator that there are new messages, like new 5 messages, right? And then you refresh to get everything. But having like 2 separate interaction patterns seems weird, so we should kind of move away from REST more to like, hey, I'm going to do a query and I'm going to subscribe to it, so every time there is a new Twitter message, I can show notification, the user can just click and the message will appear instantaneously because I already got it. I don't have to separate my notification from my data. So RethinkDB with its Horizon web backend API is doing it right. There is another player in open source called Feathers.js out of Canada, out of Vancouver, that's absolutely incredible backend built on top of Express. With like 5 lines of code, you can get both REST API and WebSocket-based connection as well. So you can have live changes in your web app just by subscribing to a service. So these 2 players will be big. This is what I think a modern web app should deal with. But that means you have to deal with streams of events.
Correct, which means that you have to think reactively, right? Like you have to, right. No, that's exactly right. I asked this because I'm starting a new project, and I'm really questioning. I'm like, it doesn't seem like I actually need a backend here, in the sense of like your traditional go make a go make a get, go make a post.
Yeah.
I mean, I don't need that, And so I'm using Firebase, and It's completely reactive, and there's no need for, besides the initial REST call on load. Everything else is automatic, So, and that's the way it should be.
If we also want to bring this around to just the probably the progressive web app discussion now, when you think about, you mentioned like the Twitter thing, updating things in the feed, think about things like displaying desktop using the notifications API to tell somebody that and a lot of things do this. Slack's website does this.
CNN.com does this.
Facebook does it. I'm starting to see more and more random websites that I'll go to ask me if they can send me notifications.
Right.
We can talk about that later, but most of the time I actually say no.
That's true.
That's a different discussion. But think about, if you were just thinking, I need to implement this, it's very easy to think about. It's very easy to think about it that way.
Right.
Where when something in the back end changes, I need to tell the user. And chat is a great example of thinking in this way. In the same way that when Firebase and a lot of these real-time databases really start to gain traction, that was their hello world type thing, was building a chat application.
Right.
But so anybody that's actually trying to learn how to do some of that stuff, think about some of those problems that you would potentially have to solve, and you can see why it works. And then when you're thinking in that way, it's very easy to interact, and then it's also very easy to jump in the middle somewhere if something changes. You don't have to rewrite a structure. You're talking about if you're doing pub sub, you don't have to worry about changing what events go to where. You can just add a new operator. And then there are also operators like in RxJS anyway, there are operators like do that don't return anything. They'll just let you act on something if you need to, for like turning a loading GIF off or something like that.
Right.
And maybe that could be used for your initial data fetch, right? Go do this.
Right.
Go get it, and then from then on, the reactive piece takes over. I'm also thinking in terms of contracts, right? So your API contracts, like you make a contract with the back end, and it's sometimes as much as we try to have like a separation of concerns and keep our business logic in at least one place. It seems like with the reactive patterns, you can have a lot more flexibility in your architecture, and just like Danny said, you can change things without interrupting without completely breaking everything else. Has that been your experience, Gleb?
I think my experience has been that I would do traditional REST kind of. User clicks a button, get like new messages or new data, and when I would do HTTP call, get data, display it. And then I would have a separate WebSocket that would display a little widget that shows, oh, you have new data available, and then the user would click. And then I would merge and I kind of think, why do I have two different patterns in my code? Right? That makes no sense. I can have my source of data be this WebSocket, and instead of just sending me an update, hey, you have new message, and when you download using REST, kind of imperative code, I could just subscribe to data. And my two different paradigms are merged into reactive. And then to your point on document or web app load, well, document load or web app load, it's just an event. I can subscribe to that, and I can kick off the whole thing. Or the user clicking a button is an event, and it can kick off the whole processing of going to the server, getting the data, and updating the DOM, just like that.
Right.
Once you start thinking, it's all the same events.
Yeah, no, you're totally right, because I'm thinking, there's a document ready event, right, that the browser hubs, so you can just listen to that and use that as your indicator. Yeah, you're right. So I think I have more questions, but Danny, do you want to?
So I want to talk about specific libraries next. So go ahead with whatever you want, and then we can get into that.
I was actually, my next question was actually, I think would fit in nicely before we talk about that, is really how do we test, reactive library, like I guess code that's written with reactive programming. And so for those who can't see Gleb, he just winced.
It's an excellent question. Whenever you have a piece of code or a new technique, if you cannot test it, it's pretty much dead on arrival. It's not something you should be using just because if you cannot test it, you probably cannot understand it, or you cannot rely on it. Having said that, the main difficulty, you can definitely set up things using regular, Mocha, or whatever your favorite test runner is. You can set up a little pipeline of events and then test the results after it finishes, or after, and so on. Observables in RxJS, for example, they always have onComplete handler, so you can subscribe to the end of a stream. So you can test, let's say, clicking of a mouse by saying, I'm going to click 3 times, and then I'm going to send I'm done event, and then your test will know when it's done. But the problem is actually more difficult. Let's say that you want to, let's say, buffer events, or say I'm going to process only 1 event per second, right? So you implement that function in your search, in your text, and now you want to test it, right? That means that your test has to wait for, let's say, 2 seconds, right? And then say, well, I only processed 1 event. Because reactive programming deals a lot with this timing, right, of events. There are multiple events. You can, there's timing, asynchronicity. And so what RxJS, for example, does, it allows you to specify a fake timer. So you can say, I'm going to create a pipeline, but instead of using real-world time, let's say 1 per second, I'm going to give you a fake timer that will simulate and say 1 second is equal to 1 millisecond, so that your test can finish in like reasonable amount of time. And actually, right now that we've transitioned between RxJS 4 to RxJS 5, that part of testing, the fake timers, how you can control the flow of events, is pretty much very minimal. And the team knows that. They're working on documenting this. But if you have to really test things, right? If you really want to get under the hood and make sure you test everything, but in a reasonable amount of time.
Feature integration tests, right?
Yes. It's almost like
I was thinking Cypress would be perfect for this.
Right. So the best thing for that would be something end-to-end testing on your website. That definitely will test the full functionality of reactive streams. But just so you know that the unit testing is still not where I want it to be. It's not as simple as testing synchronous code or callback or even event emitting code just yet. But
I was going to say, if you have very, very simple observables, it's pretty straightforward.
Yes.
Right? If just like, okay, subscribe, when you're done, run the test. So some of that stuff can actually be pretty straightforward. It's when you get into, like you said, your real-world situations, those are the things that start to be tricky. And I actually think it's kind of interesting, because we've been talking about functional reactive programming, and usually one of the flags of functional is that it's easy to test.
Yes.
But you mix that with asynchronous events, and then you start running into, again, the same problems. I mean, anybody that's had to test promises and anything else like that, it's just what happens. It's a hurdle that, like you said, they're working on. They know,
Right.
and they're working on it.
Yeah,
And
I also think that it's early days, and the community will hopefully, contribute to solving that problem, right? So it's like, I don't know if we have enough brain power on the problem.
Yeah, no, I definitely think the community knows about it, and the new testing frameworks are coming out. Even the classic frameworks, Jasmine and Mocha and those types of things. They've been working on just various solutions for their own just for basic async issues that they've solved pretty well.
Right.
So now it's almost just like the tooling part to not really the tooling part, but things like the fake timers and stuff like that, because you can also also to put something like that in perspective, you're talking about like with the buffers, and some people are like, oh, I'm not going to have to use that. Once you start moving where you're getting data in real time, you're going to run into those situations, because your backend is trying to maintain itself and making sure it's not exploding and just spitting out nonsense. But you also want to make sure that your application, specifically if you're relying on a third-party service like Firebase, you want to make sure that your application doesn't get blown up by requests coming in. So again, so you think about that, where like, so if you have a chat and you have for some reason you have 50 chats coming in at the same time, that could potentially cause problems for your user experience. But you can set up these buffers if you're doing it in a reactive way, so that even though it gets 50 of them, it's still just sending them through in a manner that the application side can handle it. So just an example for maybe if people are trying to think, well, like, I don't really see how that's a problem. You can see how that is a problem there, and then how then do you, like you said, then how then do you test that?
Right, exactly.
Without
It's hard
it
to
taking,
test, yeah.
yeah. Amel, you were absolutely right, where I think this does lead very nicely into some of the next stuff I want to talk about, which is the libraries. So this entire time we've been talking about reactive programming. We've pretty much been talking about RxJS.
Right.
And I think that's what pretty much anybody, if you hear somebody saying we're doing functional reactive programming or whatever, they're using Rx. And I think part of that is a testament to the great work that those guys have done. We have a link. I'll put a link in the show notes where we did an episode. We should actually probably do another one with some guys from the Rx team, because it's been a year, I think, since we did the last one. It's at least one job ago for me. Excuse me. But yeah, so it's... Yeah, so RxJS is what most people mean, and so I'm assuming that's what you are using as well.
Yes.
And there's also Cycle.js. I was wondering if you were using that too, Gleb, and what the difference was between the two.
Okay, let me answer this question about what frameworks or libraries for Reactive there are. So in JavaScript language land itself, there are three main players. RxJS is the largest one, and I'll explain why. There is also Bacon.js, which is called itself the hipster of reactive programming in JavaScript, and you should check it out. It has pretty much the same, but the API is a little bit different. Really good library. The main difference between Rx and Bacon.js is that Rx is actually faster. So they take benchmarks very seriously, and the Rx is very, very fast. There is a third player that I haven't used myself, and it's called Most.js. And same kind of operations, smaller API than RxJS, but Most.js is incredibly fast. So everyone thinks like Most.js somehow it's some kind of voodoo magic what they're doing, but it's incredibly fast. Now, my library of choice is RxJS, just because when we hit a problem with asynchronous programming in our Angular applications, we kind of looked around, and I played with RxJS before, and it plays nicely with Angular, and now in Angular 2 it will be part of a core, so it actually was a good decision. But RxJS is a part of a family of different languages of a library called Reactive Extensions. Out of Microsoft, started many years ago, I think, with Java implementation. So there is a Reactive Libraries.
Either Java or C#.
Yeah, one of those. I forgot which one. But they implemented the same kind of methods and the same API in many languages. So for your money, for your buck, learning RxJS way of doing things actually pays off, because you can apply it to any language. And so if you have a team working on a server in any language, be it C# or Java or whatever else, or Go, there's probably Rx, Go, Rx, Java, and so on. So it makes a lot of sense. Microsoft actually invests a lot of resources, I would say, in this family of libraries. It's very, very fast. It just has been rewritten for ES6, so there is RxJS version 5. That's very modular, implemented in TypeScript, compiles to ES6. So it makes, and it's fast. It's actually faster than Rx4. So I would say stick with RxJS for now, but certainly look at other libraries. Now, as far as Cycle.js is concerned, so at our company, we're using Angular with RxJS, right? So we kind of subscribe to events and so on, and then we have streams of things and synchronization using RxJS. But it seems a little bit of an add-on. It's kind of bolted on, right? It's not that natural, just because you still have to deal with everything else. And then you start thinking, well, if the stream of my input events just processes from my functions, never leaves any state behind, and then I can output the new DOM, let's say the new document, why can't I do it for everything? Why do I have to deal with like some internal state? And then Andreas Stahls, a guy from, well, he now works in Finland, he was thinking about functional programming and reactive programming. And functional programming has this concept of purity, where if you take a function and if it doesn't change anything outside of the function, if it doesn't access any global variables, if it only works with input arguments and produces results and doesn't leave a trace, doesn't use anything outside of itself, then you call this function pure. And so pure functional programming can scale up. You can take many pure functions, you can combine them together, you still have a pure function. And the question was, can you scale it up and build the whole web application in a way that it doesn't have external state if it's all pure? Because if it's a pure web application, it's very, very, very simple to test. And if you think about this concept of a web application that's pure, that only deals with input arguments and produces output result, what kind of input arguments would it work with? And so Andreas Stahls had an idea that the input arguments, in this case, to the whole web app should be streams, reactive streams. Let's say you have a stream that kind of encapsulates your whole DOM, your document. And then you can subscribe to this document stream and say, when someone clicks on a button in the DOM, then I'll do my stuff, my web application stuff, and then I'll output a result. But my result will be just a stream of DOM, right? So instead of me updating the DOM directly, I'll just output an event will have the new DOM to be placed in the browser. So my whole web application becomes one giant function. The inputs are reactive streams, RxJS streams. I can subscribe to them. I can do everything that web app does, but in this kind of pure fashion. I never work with DOM directly. I never subscribe to anything. I just output the new DOM after I'm done. And then the framework, the CycleJS, can kind of take care of dirty details and update the DOM in the browser and give me back another event. And so I can kind of get into loop. And that loop is called the cycle. So you kind of abstract all your side effects, your document, your location, your window access. You never deal with them directly. Instead, you subscribe to events on the input stream that you were given. You can think of HTTP as a stream that you get passed in, and you can subscribe to, I got a result from the server, I'll output a DOM with a new result, but I never deal with this directly. So CycleJS kind of takes a library of reactive streams, RxJS, adds the concept of purity and gives you this interesting framework that's really a mind-bending kind of framework. It's very hard to actually reason the way I'm used to it, right, in a cycle application, but it definitely is something that I consider the next wave of frameworks. But having said all that, so CycleJS takes RxJS streams, and then there's alternative implementation of cycle using most.js. They look around and they're like, well, RxJS is large, kind of complicated. People have struggled because there are more than 400 methods that you can deal with. And most.js has some of them, but not everything. So they wrote another library for RxJS called Xstream, X as in letter X. And that contains a very small subset of RxJS methods that really work well in a web app context. Okay, so there's another player in addition to RxJS, Bacon.js, Most.js. There is also Xstream, kind of tiny implementation, very simple API. You can plug it into CycleJS right away and kind of deal with all the events. So that's the landscape.
And so we'll put all of those in the show notes. I didn't even know about Xstream. I heard of Bacon.js. My current boss likes that. So I guess Cycle.js is pretty much kind of like an immutable. It takes an immutable, it's the DOM is kind of immutable in that sense, right? And we're always returning a new DOM.
Yes, yes. And you return a virtual DOM, so it updates only parts that are necessary. So think the best thing about React, which is virtual DOM, but without any of set state, it's all gone. You only deal with, I got an event, I'll generate the new DOM, and my browser will be updated somehow, and I don't have to deal with anything. My hands are clean. I'm done.
What I love about React is like they kind of got around the problem of the DOM being so slow when it paints, and so they're like, we're just gonna create this virtual DOM and use that, and that's how they were able to kind of achieve such like quick such great performance benchmarks early on. So,
right.
But I think you're right. Now it's time to kind of solve it in a more innovative way. So.
By the way, I just want to point out that React, despite the name, is not reactive. You still have to do like set state and component should update, right? You still execute these imperative things, right? It's not that you deal with the state changes event. You only have one state and somehow it gets updated, but you still can do like, hey, set state. So it's not a reactive framework, despite the name.
You should tweet that at them, Gleb, and see what happens.
Well, it's actually a good point. One of the first times I heard about, because I had heard about React before, and one of the first times I heard about Reactive Extensions, I thought it was something for React.
Yeah.
So it actually is a very good point that React and reactive programming are two very different things.
Yes.
All right, Gleb. So we're starting to run up against our time here. So you're obviously a fan of reactive programming. So do you have any parting words of wisdom specifically about it? If somebody's having trouble, for example, what if somebody's having trouble grokking the entire concept? Like you said, like you're saying with Cycle, it's hard for you to reason with, and a lot of people are like that with just these these asynchronous streams to begin with. So are there any good resources that you know of that are out there to help people get going?
Yes, excellent question. So we're going to share with this episode release notes, I think the link to my slides for Ozcon. So basically I have my slides and I also have all the additional links for every topic included with that link. So you can kind of start at one and keep reading, and if you have a problem with a specific area, you can follow it up. There is a huge blog post that kind of been evolving, and I've been updating it over the last 2 years. That goes together with this with the slides that explains with many code examples, kind of progress between imperative style, like through promises, to event emitters, all the way to functional reactive programming style. So that's a good resource. And another thing, I have a GitHub repo that recently got a lot of GitHub stars with the same simple code example, but implemented in all the different styles. So kind of goes together with slides and blog post. And it's a good resource because you can kind of compare and see what's the difference between imperative or object-oriented and whatever, something else. So lots of different implementations there. And I just want to point out that the best way we found for people as a team to learn about this is not for, it's not hire someone junior and give them a book and tell them, hey, read this and then come back and start working in reactive style. That doesn't work. It's not a problem between junior and senior developer. What we found the best way to actually get up to speed was as a group, as a team. We just did a book club, and we started reading books on functional programming in JavaScript. Then we started sharing and going through examples in reactive style as a group. There was never like, hey, I know this, you don't. You learn this. We kind of train together. We never assume that someone knows that and can teach others. Someone who already knows some of this can always benefit in explaining this to someone newer or learn something new. And the people who are junior can learn and grow in very non-hostile environment because everyone's learning. So train as a group, find something and share, try to explain to each other, and then you'll make progress right away.
That's great. I think that's perfect.
That's really great advice, Gleb. Thank you. Well, it feels like also with JavaScript, everyone is always a little bit junior because everything is so new sometimes.
Absolutely.
That the experts, there are very few experts in anything. So, but that's a great suggestion in collaborative learning. Yeah. Well, Gleb, this was really great. Thank you so much for your time today. So, how do people get in touch with you, and can you tell us a little bit more about where you work, and how people can get in touch with you?
Absolutely. I work at Kensher, which is a financial startup in Boston and New York City. I work out of Boston. The best way to get in touch with me probably is through Twitter, @Bahumutov, my last name on Twitter, or on my website, which is just firstandlastname.com. You'll find links to blog posts, slides, my GitHub projects, and so on. And I'm always open to questions on Twitter, email, whatever is your favorite means of communication, except for LinkedIn.
Gleb has a great blog as well. I would highly recommend everyone check it out. It's his website /blog. Really, really great blog.
All right, Gleb. Well, thank you very much for joining us. Like Amel said, this was an absolute blast. And this has been episode 94 of the Web Platform Podcast, Reactive Programming in JavaScript. And we will talk to everybody next week.